Hi, I'm Ajit Lenin. Welcome to the Enterprise Architecture video series, part 24. Last few weeks, we've been looking at architecture styles and patterns. And last week, we looked at, with the help of a few examples, we looked at how new business models creates a need for new architecture styles, how industry would look at new business model and how new styles would arrive to keep emerging. And we looked at 3 examples to kind of illustrate that. Similarly, in this week, we'll look at architecture patterns, how new business requirements could lead to new problem statements that could be common across the industry, that could lead to new architecture patterns, and new tools and frameworks would emerge based on those patterns, right? So just to illustrate that, I have come up with 3 examples. Again, this is just an illustration. There are thousands of such opportunities out there in the market. So I just picked 3 problem statements that using which I want to explain how industry new problem statements or new business requirements creates new problem statements, which can end up being common across multiple industries, which leads to common architecture patterns and then the tools and frameworks around it, right? So I've identified 3 specific problem statements, as I said. So touchpoint collector and HProxy and burst handling are just 3 names I've given for these potential patterns, right? I cannot call it patterns. This is just my thought on a potential problem statement and a potential solution, common solution for that, right? So we'll look at one by one, right? Let's look at touchpoint collector, right? So there is a growing need or a growing awareness within the industry, across the industries, right? On how do we track the customer experience, right? How do we keep track of customers could reach to the industries? I mean, it could be banking industry, telecom, it could be retail. Customer could be arriving, it could be reaching out to any channels, right? It could be digital, it could be mobile app. I mean, it could be digital meaning web, or it could be mobile app, or calling to the call center. So whatever way the customer reaches, and there could be multiple touch points. Customer may be for a single transaction, customer may be calling multiple times. Customer may be receiving communications, customer may be reacting to that. So there is a growing need or growing awareness in the industry to see how do the customer go through these touch points, right? What is the journey of the customer for that particular use case or a transaction? Right. So that is needed for a new way of doing business. So primarily, we are looking at insights-driven experience going forward, right? I mean, a lot of companies already are doing that, and then across industries, it is becoming a standard. So we'll look at the touch points customer has gone through, and based on that, how do we derive insights and then deliver an experience to the customer based on that, right? That's one aspect. The other aspect is how do we track the customer, the full journey of the customer, and so that we can drive insights, identify pain points within the experience, right? Rather than depending on a manual feedback from the customer, how do we measure the experience and derive feedback, right? Or systematically. So for all this, there is a need to collect the events, right? Or collect the touch points the customer has gone through. It could be a customer touch point where customer reaching out to us, or it could be a system generated touch point, right? So like a bill being generated for a monthly service, right? It could be a utility or a telecom, whatever it is. A monthly bill generated is a event that impacts the customer, right? Those it's automatically, systematically generated, it impacts customer. So what is the journey of so we need to have, there is a need for to collect all these touch points across and all these different channels or applications where the customer has the touch points are different, could be different applications. So we need a common, there's a need for have a common solution where we could collect all these events and then provide ability to consume this event so that we can, one is we can provide insights for delivering better customer experience. The other is to basically understand and derive, identify pain points, etc. Right. So it's a common solution. Right in today's world, most of these industries are doing it in themselves, but it could, as the problem statement becomes more and more common, a common pattern could solution or the architecture pattern could emerge, right? So this is just my thought process on how this could emerge, right? So all these applications could send data through a data streaming platform. It could be any data streaming platform. And the primary aspect of the event collector would be an event store, which keeps collecting the data from the data stream. And there could be a standardization of the messages coming through so that the integration of applications becomes standardized and easy. So there, I mean, it needs to have capabilities to identify. I have just identified a few potential attributes that could come in. So the interaction identifier itself, the touch point, on within that interaction, what touch point it is, what channel or application where this touch point is happening, the timestamp, and also the customer bindings could be an account ID or a customer name or a customer contact ID, or any of these binding identifiers, and then a touch point specific set of attributes, right? So there could be a standardization of the message. So a stream of messages following this standard keeps coming to the data stream, and an event store just keeps collecting it. And there could be an event consumption API and a data distribution, so that this event data could be provided to some offline analytics platform or an AI model to study how the customer journey was, right? So this is just a simple pattern that could currently a lot of companies a lot of industry enterprises are implementing it. It's just that once it becomes more and more common, there could be there's an opportunity for a architecture pattern to evolve from this, right? So the next example is I'm calling it as HProxy. So this I would say is an extension of the forward proxy pattern we have already seen, right? So it's a pretty common pattern across, right? So in the growing new world, right, pretty much in the near future. So at this moment, there are a lot of telecom companies or communication service providers who actually are actively engaged in implementing edge locations, right? With 5G coming into picture, the focus would be on how do we create an infrastructure to deliver low latency services, right? So edge becomes the near edge compute becomes an important aspect of it, right? So as within the next couple of years, we would see a lot of near edge compute locations across the world, right? Where a mobile app user or an IoT module could get near real-time responses back, right? It could be based on, say, it could be a streaming platform, gaming platform. It could be a automated factory arrangement. So these edge locations could be private edge locations or a public edge where people can deploy their services and can be consumed. So this ecosystem, as this ecosystem evolves, there will be a need for the client applications, right? Could be mobile apps or IoT modules to connect to the right edge locations, right? Because the services could be deployed across multiple edge locations. So we need to figure out where do we connect to, right? The traditional load balancing patterns may not work here. Traditional load balancing patterns which are, work across one or two clusters may not really work here because these edge locations could be varied across geographies across the world, and having a load balancer kind of a pattern would defeat the low latency aspect of it, right? So the clients should determine which edge location it needs to collect to, right? So there needs to be a proxy which would just abstract the client apps from the service. Also, it will take the additional responsibility of first determining which edge to connect to. So typically, all these service providers should provide an edge discovery service where we can say that for this service, what are the edges available to me, and what are the potential latencies for that, right? And based on this, the proxy can make a decision saying that for this particular service, I'm going to go and hit this edge location, right? And also, it needs to keep watching on the SLAs, right? So the moment it sees that a particular edge location is not serving the purpose, I mean, it's not able to fulfill the latency, it should look for a new edge location. That's a pretty common pattern that would have emerged because as a mobile user on the move, they need to connect to a different edge location when they move from one geography location to another, right? So this is a problem statement, still not a very common problem statement. It could become a problem statement in the in the next couple of years. And there could be a lot of people trying to solve this problem statement. And this is my view on how this could be a simple pattern for how do we solve this problem, right? And this could become an architecture pattern, and there could be a lot of tools and frameworks would come around it, right? The next um, example or a problem statement I thought about is the what I call is burst handling. In today's world, any business we take, right, there is the peak there is a variations in traffic. Like there are busy times and low uh, times where the business is low, right? Meaning say it could be seasonal or it could be based on certain events, right? So like if we take a banking industry, there could be peak time in the mornings and the evening times, and the time between could be very low traffic, right? Similar thing on retail shopping. So weekends probably a high traffic time for retail sites, right? Or it could be based on an event. There could be holiday seasons where the traffic would be more, or it could be based on events, right? So for a typical customer communication service provider, a launch of a phone, right? And a launch of iPhone could drive a lot of traffic into customer service providers, right? So it could be seasonal as well as event based, right? In today's world, the cloud-based infrastructure has provided us ability for all the enterprises to scale up and down based on need, right? But when we scale up, it actually there is a cost involved to it, right? So as the need to scale up comes in, there is always an opportunity to balance the cost by cutting down of the non-priority um, computing, right? It could be jobs or any asynchronous process that could be running, right? So there's always an opportunity to cut down the cost when we have to scale up. How do we compensate for that? Cutting down some of the non-priority compute, right? And if we leave it to the individual applications to cut it down, it's going to be very hard to manage, right? So we need there is a common problem statement that could come in saying that we need a solution to identify when the traffic is high, when the burst is happening, and be able to notify all the applications saying that, yeah, this is a burst time. Let's cut down on the non-priority compute, right? So based on that, each application can take an action, right? They can cut down some of the jobs that are running, some of the processing they can just dump into a DB and wait, process the request later, right? Etc. A lot of ways. There are a lot of ways we can handle this, but we need a common solution which can listen to the critical traffic, right? It could be one or two applications which would be the critical where the critical traffic would be flowing. So it can intercept the traffic and say identify based on some thresholds. It can identify that this is a burst time or a non-burst time, right? So when it comes into a burst, it can send a notification to all the applications, and the applications can take an action and acknowledge back. Similarly, when the traffic goes down, it can say that, oh, now its burst is down. Now you can go ahead and notify the applications back and say that now you can start your non-priority compute, right? So that's one way of managing the burst. The other is the schedule. So when it's seasonal or based on a pattern, like if it's every day morning 8 to 10 is the peak, so we can have a 8 to 10 identifiers of burst. So this burst handler should have the ability to manage the schedule as well, right? So it could be scheduled or unscheduled way of managing the burst. So this is a common problem statement that it's there in the industry, right? So the need for it will increase as the companies become more and more aware of the compute cost on the cloud, right? So this could be a pattern that could emerge. Just as my thoughts on this could be a pattern that could emerge in the industry soon, right? So with these three examples, I just wanted to illustrate that there are thousands of problem statements like this, and the new problem, and as the business requirements change, with new business models comes in, there are new problem statements comes in, and hundreds of those problem statements could be common across industries, and that would drive to new patterns, and that patterns add to the enterprise, basically help the enterprise architecture world progress and will help the enterprise architecture to solve the problems for the enterprises. With that, I will like to summarize. So we looked at some sample set of opportunities for architecture patterns. Touchpoint, collector, HProxy, and burst handler are three examples we looked at, right? With this, we are pretty much completing the enterprise architecture video series I've been running for the last 24 weeks. Next week, I'll try to conclude the overall video series with some summarization of all the topics we covered across the 24 weeks. And then we'll close down the video series. Thank you.